We are going to start now the next lecture, lecture 3 of chapter 8, class 10th mathematics, introduction to trigonometry. In this lecture, we will talk about certain questions and problem based upon the identities that we have already proved. So the identities that we have proved, we are saying these values. First we have the equation sine square theta plus cos square theta is equal to 1, and we are saying this is an trigonometric identity. Identity means that it is true for all values of angle. Whatever value of angle you will substitute in it, angle means whatever value of theta you will substitute in it, these identities these hold for all the angles. So if we look at this first identity, we can write that it can be written in the form that sine square theta is equal to 1 minus cos square theta, or it can be written in the form cos square theta is equal to 1 minus sine square theta. Similarly, this identity, this can be written as 1 is equal to secant square theta minus tan square theta, and this identity we are saying this can be written in the form 1 is equal to cosecant square theta minus cot square theta. Why we are writing it in this form? Because if suppose somewhere we are given sine square theta, we can write it in the form 1 minus cos square theta. We can substitute the value of 1 anywhere as secant square theta minus tan square theta or cosecant square theta minus cot square theta. So what we are saying, if suppose somewhere 1 is written, it may be we can replace it with the term sine square theta plus cos square theta. This is also equal to secant square theta minus tan square theta, and this is equal to cosecant square theta minus cot square theta. We are saying all these values, these are equal to each other. So based upon these, we have to prove certain questions, certain equalities we are talking about. So the first is 1 minus sine square theta is equal to secant square theta. Now from this first identity, what we have is, we are talking about this identity, it is 1 minus sine square theta is equal to cos square theta. It means this value we are saying 1 minus sine square theta, we can write it is cos square theta. Next it is secant square theta, and secant we know it is 1 over cos square theta. If we multiply both of these, answer we will get it is 1. So how we are going to solve this is, we are going to write LHS, that is equal to 1 minus sine square theta into secant square theta. Then we are saying by using this identity, we get this is equal to cos square theta into secant square theta is 1 over cos square theta. The final answer we are getting equal to 1, and this is the RHS that we have. So we are saying hence this result is proved. Similarly, in the next second one, we have 1 plus tan square theta into cos square theta. This is the LHS part. What is 1 plus tan square theta? We are talking about now the second identity, 1 plus tan square theta, that is equal to secant square theta into cos square theta, and we know that the product of these two terms, it is 1. We are saying what results we have, it is secant theta is equal to 1 over cos theta. So this gives us secant theta into cos theta is equal to 1. So secant theta is equal to 1 over sine theta. So this gives us cosecant theta into sine theta, that is equal to 1. Then cot theta is equal to 1 over tan theta. So this means cot theta into tan theta is equal to 1. We will not repeat these things again and again. These we can use just like the identities, that secant theta into cos theta is 1. Second, we are saying cosecant theta into sine theta is equal to 1. And third, we are saying it is cot theta into tan theta is equal to 1. Now in this third question, we are talking about this third part. We have 1 LHS we are talking about. LHS is 1 plus tan square theta. And when we are talking about these two terms, we are talking about 1 minus sine theta into 1 plus sine theta. This is the formula for, we are saying a minus b into a plus b, and the value we know this is equal to a square minus b square, and we are going to write it is 1 minus sine square theta. Now from this second identity, 1 plus tan square theta is secant square theta. This is secant square theta, and 1 minus sine square theta we know it is cos square theta. Secant square into cos square theta, that is equal to 1, and that is equal to RHS. Now the next question we have, it is 2 times cos square theta plus 2 over 1 plus cot square theta. We are saying it is 2 cos square theta plus 2 over 1 plus cot square theta. What is 1 plus cot square theta? Look at this identity over here. It is cosecant square theta. 2 we have taken common, so it is cos square theta plus 1 over cosecant square theta. What is 1 over cosecant square theta? It is sine square theta, because 1 over sine theta, that is equal to cosecant theta. This identity we are talking about. So what we are left with is 2 times cos square theta plus sine square theta, and the answer we will get, that is equal to 2, because this whole term will be equal to 1, and we are saying this is equal to the RHS. This is the LHS value, that is equal to RHS. So we are saying that this equation, it is proved. Next is we have to prove that cosecant square theta minus 1 into tan square theta equal to 1. So we are considering the LHS part. Now if we look at this equation, we are talking about this third equation. We are saying if we shift this one on the other side, we get cot square theta is equal to cosecant square theta minus 1. It means this value is cot square theta into tan square theta. So it is cot theta into tan theta square. The value of cot theta into tan theta, it is 1. So the answer we are getting, that is equal to 1, and that is equal to RHS. Similarly, in the second part, we are saying from this equation, the second one, we are saying we can deduce that tan square theta is equal to secant square theta minus 1. We are having the value secant square theta minus 1, that is tan square theta, and so secant square theta minus 1, that is equal to cot square theta. The product of these two values, we are saying that is equal to this is minus of cot, because secant square theta minus 1, that is cot square theta. So we get 1 minus cosecant square theta, that is equal to minus of cot square theta. We have substituted this value over here. Minus sign will come out, and we are left with this tan theta into cot theta square. So the answer we get, it is minus 1. So we are saying this is equal to the RHS. Next is sine cube theta plus cos cube theta over sine theta plus cos theta plus sine theta cos theta. Now we know the identity that a cube plus b cube, that is equal to a plus b into a square plus b square minus ab. It means sine cube theta plus cos cube theta, that is equal to sine theta plus cos theta into sine square theta plus cos square theta minus sine theta into cos theta. If we divide this term on this side, we get it is over sine theta plus cos theta. We are talking about this whole value. This is this term, we are saying this is the first term over here. So what we are left with is this. Look at this term, sine square theta plus cos square theta. what we have is sin square theta plus cos square theta is equal to 1. It means this term will become 1. So what we are left with is 1 minus sin theta cos theta in place of this term, plus this term we have as it is sin theta into cos theta. These two terms they get cancelled and the answer we are left with 1, and that is equal to RHS. Now the next we have to prove that this sin theta minus secant theta into cos theta minus secant, this is cosecant theta and secant theta, that is equal to 1 over tan theta plus cot theta. So if we are talking about the identity sin square theta plus cos square theta, that is equal to 1. So suppose we are solving this problem and we have started with left hand side. So left hand side is sin theta minus 1 over sin theta, because cosecant theta is 1 over sin theta, into cos theta minus 1 over cos theta. So this comes out to be sin square theta minus 1 over sin theta into cos square theta minus 1 over cos theta. Now from this equation we have sin square theta minus 1, that is equal to minus of cos square theta, and cos square theta minus 1, that is equal to minus of sin square theta. So we are saying in place of this we can write minus of sin square theta. In place of this we can write it as minus of cos square theta. Now on solving this, what we will get, this minus minus sign gets cancelled, this sin theta and sin theta get cancelled, this cos theta and cos theta get cancelled, and what we are left with is cos theta into sin theta. Now this value, if we compare it with the right hand side, it is not equal to this. So we start simplifying the right hand side. It seems that these two values, these are not equal. So what we are trying to do is, we are trying to solve the right hand side now. So it is 1 over tan theta plus cot theta. So this is equal to 1 over sin theta by cos theta plus cos theta by sin theta. If we take the LCM over here, it is cos theta into sin theta, and terms over here they are sin square theta plus cos square theta. Now what is sin square theta plus cos square theta? It is equal to 1. So what we get is cos theta into sin theta, and from this what we are saying is that both these values, sin theta into cos theta, so both these values we are saying LHS is equal to RHS. So it means this equality, it is proved. Next is prove that 1 plus cot theta minus cosecant theta into 1 plus tan theta plus secant theta is equal to 2. So we start this with left hand side, and it is 1 plus cos theta over sin theta minus 1 over sin theta into 1 plus, in place of tan theta we can write it as sin theta over cos theta plus 1 over cos theta. So if we take the LCM for both these terms, we are saying sin theta is the LCM over here, and the terms we will get it is sin theta plus cos theta minus 1 into cos theta plus sin theta plus 1 over cos theta. Now look at these two terms, it is sin theta plus cos theta, sin theta plus cos theta. So we put both these terms in the bracket. So and the formula we are saying, suppose this term we are saying this is A, this whole terms we are saying it is A, and 1 is equal to B. So what we have is A plus B into A minus B, and that formula will be A square, that is sin theta plus cos theta square minus B square over, this is sin theta into cos theta. If we open this bracket, we are talking about this term, what we will get it is sin square theta plus cos square theta plus 2 sin theta cos theta minus 1 over sin theta into cos theta. Now what is the value of sin square theta plus cos square theta? The value of sin square theta plus cos square theta, this value is 1. So this 1 and this minus 1 gets cancelled. So what we are left with is 2 sin theta cos theta over sin theta cos theta. This sin theta cos theta gets cancelled and the answer we are left with is 2. Now next is left hand side we are considering over here. LHS we have, it is cos theta over 1 minus tan theta plus sin theta over 1 minus cot theta. We can write it is cos theta over 1 minus sin theta over cos theta plus sin theta over 1 minus cos theta over sin theta. We are writing in place of tan theta, we are writing sin theta over cos theta, and in place of cot theta we have written cos theta over sin theta. Now this denominator part we are talking about, if we take the LCM, it is over cos theta minus sin theta. This denominator part we are taking sin theta as LCM, so it is sin theta minus cos theta. So on adjusting these terms we get it is cos square theta, this denominator part will come in the numerator, and we are left with is cos theta minus sin theta. Suppose from this term we are taking minus sign common, so what we are left with is minus sin square theta over cos theta minus sin theta. We have taken the minus sign common from both these terms, so we are left with this. So we are writing it is equal to cos square theta minus sin square theta over cos theta minus sin theta whole square. We are talking about a square minus b square is equal to a plus b into a minus b. So it is cos square theta minus sin square theta, that is equal to cos theta plus sin theta into cos theta minus sin theta. We are saying this is cos theta plus sin theta into cos theta minus sin theta upon the denominator part we have, it is cos theta minus sin theta. These two gets cancelled and this part that we are getting, this is equal to RHS. So what we are saying is that LHS is equal to RHS. Now in this next question, it is LHS we are talking about. From the LHS, from the numerator part we are taking sin theta common and we are left with is 1 minus 2 sin square theta. In the denominator we have taken cos theta common and what we are left with is 2 cos square theta minus 1. This is the LHS part we are talking about. Now suppose we are converting this sin square theta to cos square theta. So what we have is that sin square theta is equal to 1 minus cos square theta. You substitute this value in this, I am talking about this part only. So this will become 1 minus 2 into 1 minus cos square theta. So this is 1 minus 2 plus 2 cos square theta. This is equal to 2 cos square theta minus 1. Now this part 2 cos square theta minus 1 and 2 cos square theta minus 1 gets cancelled and what we are left with is sin theta over cos theta, that is equal to tan theta and that is equal to RHS. Next is we have to prove that tan A plus sin A over tan A minus sin A. We are considering the left hand side of the first equation. Now we can write tan A as sin A over cos A plus sin A over sine A over cos A minus sine A. If we take sine A common from this, what we are left with is 1 over cos A plus 1. We are taking sine A common from this, we are left with is 1 over cos A minus 1. This sine A gets cancelled. If we take the LCM over here, we are left with cos A 1 plus cos A over 1 minus cos A over cos A. Now this term is equal to 1 plus cos A over cos A into 1 minus cos, we are saying it is into cos A over 1 minus cos A. These two gets cancelled, and what we are answer we are getting it is 1 plus cos A over 1 minus cos A. Now if we multiply and divide the numerator by 1 over cos A, we are multiplying and divide the numerator and denominator by 1 over cos A. The answer we are left with is 1 over cos A plus 1 over 1 over cos A minus 1. And what is 1 over cos A? That is equal to secant of A. What is 1 over cos A? It is secant of A. So the answer we obtain, it is secant A plus 1 over secant A minus 1. Similarly, in the second part, we have cos A over sin A minus cos A over cos A over sin A plus cos A. If we take cos A common, we are left with 1 over sin A minus 1. Cos A is common, we are left with 1 over sin A plus 1. Cos A gets cancelled, and the answer we are left with is 1 minus sin A over sin A into sin A over 1 plus sin A. Sin A gets cancelled. Now if we multiply the numerator with 1 over sin A, we multiply the denominator with 1 over sin A, we get 1 over sin A minus 1 over 1 over sin A plus 1, that is equal to cosecant A minus 1 over cosecant A plus 1, and this is equal to RHS. Now in this next question, the LHS we have, it is tan A over 1 minus cot A, so it is sin A over 1 minus cos A over sin A plus, it is sin A over cos A we are saying, and cot A is cos A over sin A over 1 minus sin A over cos A. Now in this denominator part, if we will take the LCM, we will get the answer is sin A over cos A into sin A over sin A minus cos A. And the second we are writing it is cos A over sin A into cos A over cos A minus sin A. So from these two terms, what we get is, if we take 1 over sin A minus cos A common from both these terms, from the first we are saying it is sin square A over cos A. We have taken sin A minus cos A common, it is cos A minus sin A. I am saying this value, this term is sin A, this is sin A. So in the second bracket, first of all this sign is changed to negative sign, then we are left with this cos square A over sin A. Now on taking the LCM, we will get it is 1 over sine of a minus cos of a into sine cube a minus cos cube a over sine a into cos a. Now what is the formula for a cube minus b cube? It is a minus b into a square plus b square plus ab. So we are saying that we can write this term as 1 over sine a minus cos a. This is a cube minus b cube. So it is sine a minus cos a into sine square a plus cos square a minus sine a cos a and divided by cos a sine a. These two terms they get cancelled. Sine square a plus cos square a, this is equal to 1. So what we get is that 1 minus sine a, we are saying the sign that we will have over here, it is cos a, this is plus sign over here, it is not minus sign, over sine a into cos a. So this is the value of our left hand side. Now we are solving the right hand side. We are talking about the RHS part. So in the RHS part we have 1 plus tan a plus cot a. This we can write, this is equal to 1 plus sine a over cos a plus cos a over sine a. If we take the LCM, we get it is sine a cos a, and the value we get it is sine a cos a plus sine square a plus cos square a. Sine square a plus cos square a, it is 1. So what we get is that both these values, these are equal, and this is what we have to prove. Now in the next question we have cosecant a minus sine a. So cosecant we can write it is 1 over sine a minus sine of a into 1 over cos a minus cos of a. If we take the LCM, in this term we are talking about, when we take the LCM, it is over sine a 1 minus sine square a. This is cos a 1 minus cos square a. 1 minus sine square a, this is equal to cos square a, and 1 minus cos square a, this is equal to sine square a. So this sine a and sine square a, this cos a and cos square a gets cancelled, and the answer we are left with is cos a into sine a. This is the value of LHS that we have. Next we are solving the RHS part. RHS is 1 over sine a over cos a plus cos a over sine of a. When we take the LCM, we get it is sine a into cos a. This is sine square a plus cos square a, and this whole value, this is equal to 1. This sine square a plus cos square a, we are saying it is equal to 1 by our identity. So the answer we will get is that 1 into sine a cos a. Why we are getting? It is 1 over a by b, that is equal to b by a. So this denominator will come over here. Similarly, this denominator will come over here, and the answer we are getting, it is sine a into cos a. So what we are saying, that this is the LHS, this is the RHS, both are equal. So we have proved this result. Now the next we have, it is these three terms, these are given to us. So if we start solving the first one, it is 1 plus tan square a over 1 plus cot square a. Now from the identity we know that these two identities, we are saying this is equal to secant square a over cosecant square a. This is equal to 1 over secant square a, we can write it as cos square a over 1 over sine square a. This is 1 over cos square a into sine square a. This is equal to sine a over cos a whole square, and the answer we get, that is equal to tan square a. Now for the second equality, we are considering this term. We are saying it is 1 minus sine a over cos a over 1 minus cos a over sine a, and it is whole square over here, and this will be equal to cos a minus sine a over cos a whole square over sine a minus cos a over sine a whole square. So this is equal to cos a minus sine a square over cos square a into sine square a over, we are saying it is square on this term, so we can write it in the form, we can write this term as cos a minus sine a whole square. These two terms get cancelled, and the answer we are left with is tan square a, and this is what we have to prove. So we are saying that all these three terms, they are equal to each other. Now next we have a secant square theta plus cosecant square theta. We have to prove this. So in place of secant square, we can write it as 1 over cos square theta plus 1 over sin square theta. This is the LHS we are talking about. When we take the LCM, it is sin square theta into cos square theta, and it is sin square theta plus cos square theta. This numerator becomes 1, and we are left with is 1 over sin square theta into 1 over cos square theta. What is 1 over sin? It is cosecant square theta into secant square theta, and that is equal to RHS. In the second part, it is tan square theta minus sin square theta. So we can write it is sin square theta over cos square theta minus sin square theta. If we take sin square theta common, we are left with 1 over cos square theta minus 1. This is sin square theta into 1 minus cos square theta over cos square theta. Now look at this identity over here. What we get is that 1 minus cos square theta, that is equal to sin square theta. So we get it is sin square theta is already there, then it is sin square theta over cos square theta, and the answer we get it is sin square theta into tan square theta. So this is what we have to prove, that it is tan square theta into sin square theta. Now the last part we have, it is tan square theta plus cot square theta plus 2. This is the left hand side we are talking about, and we have to prove that it is equal to secant square theta into cosecant square theta. So we are saying this is 2 into 1. In place of this 1, we can write it is tan theta into cot theta, because the product of these two terms, it is 1. So this whole term we are talking about, this will be tan theta plus cot theta whole square, and this we can write it is sin theta over cos theta plus cos theta over sin theta whole square. If we take the LCM over here, it is sin theta into cos theta, it is square over here, and in the numerator we will get it is sin square theta plus cos square theta. And what is the value of sin square theta plus cos square theta? The value of sin square theta plus cos square theta is 1, and the answer we are left with is 1 over sin square theta into 1 over cos square theta. 1 over sin square theta, it is secant square theta, and 1 over cos square theta, it is secant square theta, and 1 over sin square theta, it is cosecant square theta. So we are saying this is equal to cosecant square theta into secant square theta, and this is what we have to prove. Now another kind of proof is given over here, that what we have done is 2 we have 1 plus 1. We have written this 2 as 1 plus. Then we have used the identity 1 plus tan. This is secant square theta. 1 plus cot square theta, it is cosecant square theta. So on solving these values, we will get it is 1 over cos square theta plus sin square theta, and on solving this we will get the answer as secant square theta into cosecant square theta. So it is up to you that how you want to prove this identity. You can use any one of these two methods. Now next we have is this term, we have it is cosecant theta. So we can write it is 1 over sin theta minus cos theta over sin theta, and it is whole square over here. If we take sin theta as LCM, we are left with this 1 minus cos theta. So it is 1 minus cos theta square over sin square theta, and this comes out to be 1 minus cos theta into 1 plus cos theta over. The identity we have, it is sin square theta plus cos square theta is equal to 1. So we can write sin square theta is equal to 1 minus cos square theta. 1 minus cos square theta is, we are writing 1 minus cos theta into 1 plus cos theta. It means the denominator we get, it is 1 minus cos theta into 1 plus cos theta. This term gets cancelled, and the answer we are left with is 1 plus cos theta over 1 minus cos theta, and that is equal to the RHS. Now next we have, it is secant 4 theta minus secant square theta. So from this term we can take secant square theta common, and we are left with is secant square theta minus 1. Look at this second identity over here. What is secant square theta minus 1? That value will be, it is secant square theta into tan square theta. We are getting from this that secant square theta minus 1 is equal to tan square theta. Similarly, when we are talking about this term and we are taking tan square theta common, we are left with is 1 plus tan square theta. And what is the value of 1 plus tan square theta? It is secant square theta. So the answers we are saying, this is the left hand side, secant square theta into tan square theta. This is the right hand side, it is secant square theta into tan square theta. Both these values, these are equal. So we are saying that the identity is proved. Next we have is 1 plus 1 over tan square theta plus 1 over 1 plus cot square theta. So if we take the LCM over here, we will get it is tan square A plus 1 over tan square A into cot square A plus 1 over cot square A. This is the left hand side we are seeing. Now tan square A plus 1, this is equal to secant square theta, and cot square A plus 1, this is equal to secant square theta. In the denominator we have tan square A into cot square A, and the product of these two values, this is equal to 1. From this part we are saying, when we are considering the RHS, we are saying we have taken 1 over sin square theta common, and we are left with is 1 minus sin square A. It is not theta, it is A over here. So we are writing it is 1 minus sin square A. And what is value of 1 minus sin square A? It is 1 over sin square A into, from this identity we are saying this value will be equal to cos square A, and this is equal to cosecant square A into secant square A. So what we get is that the LHS part, it is this, RHS part it is this, and both these values, these are equal. So we are saying that RHS is equal to LHS. Now next, this identity is given. So if we consider the left hand side over, this is left hand side, and we open this whole square term, we will get it is sine square theta plus cosecant square theta plus 2 sine theta into cosecant theta. This is corresponding to this first square. Corresponding to this second square, we will get it is cos square theta plus secant square theta plus 2 times cos theta into secant theta. Look at this term, it is 2 cos theta into secant theta. What is cos theta into secant theta? It is 1. Sin theta into cosecant theta, it is 1. This is sin square theta plus cos square theta. This value is 1. Next we are left with this cosecant square theta plus secant square theta. So the final answer we are saying after solving these terms, we are saying sin square theta plus cos square theta, it is 1. Then we are left with this 2 from this, 2 from this term, and last term we are left with it is cosecant square theta plus secant square theta. The answers we want, they are in the terms of tan theta and cot theta. So we write cosecant square theta is equal to 1 plus cot square theta, and secant square theta is equal to 1 plus tan square theta. So what we get is, it is 2 plus 2, 4, 5, 6 and 7 plus tan square theta plus cot square theta, and this is what we have to prove. Now in this question, we start solving from this side. If you want to solve from the left hand side, you can rationalize this term. You can multiply and divide it with 1 minus sin theta, and you will get the answer. Otherwise, what we are going to do, we are writing this term as 1 over cos theta minus sin theta over cos theta square. This will give us 1 minus sin theta square over cos square theta. We can write cos square theta is equal to, the numerator is 1 over sin theta square. We are saying we can write cos square theta, that is equal to 1 minus sin square theta. This is from our first identity, and this is equal to 1 minus sin theta into 1 plus sin theta. So we are saying the denominator we have, it is 1 plus sin theta into 1 minus sin theta. This 1 minus sin theta get cancelled, and the answer we are left with is 1 minus sin theta over 1 plus sin theta. Now in place of this, if suppose we are not solving it in this form, what we have to do, I am talking about the second part over here. The terms we have, it is 1 plus cos theta over 1 minus cos theta. What we are going to do, we are multiplying it with 1 plus cos theta and dividing it with 1 plus cos theta. The numerator part, it will become 1 plus cos theta whole square, and denominator is 1 minus cos square theta. Now if we look at this denominator over here, it is 1 minus cos square theta, and the value of 1 minus cos, numerator is 1 plus cos theta whole square, and the denominator is sin square theta. We can write it is 1 plus cos theta over sin theta whole square. If we separate these denominators, we will get it is 1 over sin theta plus cos theta over sin theta, and we are getting it is whole square of this term. Now what is 1 over sin theta? It is cosecant theta. What is cos theta over sin theta? It is cot theta, and this is what we have to prove, that it is cosecant theta plus cot theta whole square. Now next we have the first part, we have it is 1 over cosecant theta minus cot theta, and we have to prove that it is equal to cosecant theta plus cot theta. So we are multiplying it with cosecant theta plus cot theta, and dividing it with cosecant theta plus cot theta. Now look at this denominator over here. This is a minus b into a plus b. So it is a square minus b square, that is cosecant square theta minus cot square theta. Now from this third identity, what is cosecant square theta minus cot square theta? This is equal to 1. So the answer, this is the denominator part we are talking about. This denominator will be equal to 1 and the answer we are left with is cosecant theta plus cot theta. Now for the second part, we are saying it is secant theta minus tan theta over secant theta plus tan theta. We multiply and divide it with secant theta minus tan theta over secant theta minus tan theta. So numerator will become whole square. We open this square, we will get it is secant square theta plus tan square theta minus 2 secant theta tan theta over, it is secant square theta minus tan square theta. Now what is the value of secant square theta minus tan square theta? Look at the second identity over here. This denominator value, this will be equal to 1. Now the answer we want, it is in terms of tan square. So in place of secant square, we are writing it is 1 plus tan square theta, the secant square theta. So the final answer we will get, it is 1 plus 2 tan square theta minus 2 secant theta tan theta. Next is we have to prove that 1 over cosecant theta minus cot theta minus 1 over sin theta, this is equal to this term. So we start with the LHS part. So it is 1 over cosecant theta minus cot theta minus 1 over sin theta. We are multiplying it with cosecant theta plus cot theta and dividing it with cosecant theta minus cot theta. This whole term, denominator part I am talking about, this will become cosecant square theta minus cot square theta, and this value is equal to 1 because of our third identity. So what we are left with is, it is cosecant theta plus cot theta minus, what is 1 over sin theta? It is cosecant theta. So answer we get, it is cot theta. Now this is the LHS part. Similarly for RHS, we are saying it is 1 over sin theta minus 1 over cosecant theta plus cot theta. We are multiplying it with cosecant theta minus cot theta, dividing it with cosecant theta minus cot theta. 1 over sin theta, it is cosecant theta. The product of these two terms, that is equal to 1. So cosecant theta gets cancelled and the answer we are left with is cot theta, and we can see that LHS is equal to RHS, and this is what we have to prove. Next is prove that 1 over secant theta minus tan theta minus cos theta is equal to this. So again this is similar kind of question. So what we have done, we have considered this LHS part, we have multiplied and divided it with secant theta plus tan theta. We have used this identity in the form that 1 is equal to secant square theta minus tan square theta. This is the denominator we are getting in this case. Then we are writing 1 over cos theta as secant theta, and the final answer we are getting, it is tan theta. On the right hand side, we have multiplied and divided it with secant theta minus tan theta, and on solving this we will get the answer is tan theta, and we are saying that LHS is equal to RHS. So both these questions, these are similar questions that we have to multiply and divide these terms over here to get the answer. Now how we come to know that we are going to do this is that one hint we can get from is that all these terms over here, they are not having squares. These terms are not having squares. So first of all, we want to simplify in these terms in such that we get the squares on these terms, because all the identities that we have, they involve the square terms. Second thing is, we are looking at this term over here. It is secant theta plus tan theta, and from this identity we know that if we multiply this term with secant theta minus tan theta, we can use this kind of identity. Suppose you change all these terms to sin theta and cos theta. It is not like this that you will not get the answer. You will get the answer, but it might get difficult and the calculation might become very lengthy. I am talking about that if you start solving it in this form, that you start writing it as 1 over cos theta over sin theta over cos theta minus 1 over cos theta. Then you solve the left hand side. Then you solve the right hand side. You will get the answer. It is not like this that you will not get the answer, but the calculations, they will become very lengthy. So to reduce these calculations, by keeping this identity in mind, we have multiplied and divided this equation with secant theta plus tan theta. Now the next question we have, it is sin theta over 1 minus cos theta, that is equal to cosecant theta plus cot theta. We have to prove this. So we start with the LHS, that is sin theta over 1 minus cos theta. Again, if we look at these terms, the power over here for sin as cos, it is 1. So one of the approaches to solve this is that we multiply and divide the numerator and denominator with 1 plus cos theta. This term is 1 minus cos theta, so we have multiplied and divided it with 1 plus cos theta. So the answer we will get, that is equal to sin theta into 1 plus cos theta over 1 minus cos square theta. The value of 1 minus cos square theta is sin square theta. So this denominator becomes sin square theta. This sin theta and sin square theta gets cancelled, and we are left with this 1 over sin theta plus cos theta over sin theta, and the answer we get, it is cosecant theta plus cot theta. Now the next question we have, it is 1 over secant theta minus tan theta. Again, the power of all these terms, it is 1. So to solve this, we are multiplying and dividing it with secant theta plus tan theta over secant theta plus tan theta. This will become secant theta plus tan theta over secant square theta minus tan square theta. Using the second identity, we get secant square theta minus tan square theta, that is equal to 1. So it means this denominator will become 1 and this term will become equal to RHS. Now next in this question, the LHS that is given to us, it is of the form secant theta plus tan theta minus 1 over tan theta minus secant theta plus 1. So we can write these terms in the form, it is secant theta. We are writing this in the form, we are not writing secant theta, we can write it in the form, it is tan theta plus secant theta minus 1, and in the denominator we have, it is tan theta minus, we have taken common, what we are left with is secant theta minus 1. If we put bracket on this term, what we see is this term we have, it is secant theta minus 1, secant theta minus 1. This term over we have, it is tan theta. So what we are going to multiply and divide over here, it is tan theta minus, I think it is plus secant theta minus 1 over tan theta plus secant theta minus 1. We are saying this is secant theta minus 1, this second term, and the first term it is tan theta. It was minus sign over here, so we have taken this sign as plus sign. So if we multiply both these terms, what we will get is, it is tan theta plus secant theta minus 1 whole square over tan square theta minus secant theta minus 1 whole square. We are saying this term tan theta is just like A, this whole term is like B, this term is like A, this whole term is like B. So in the denominator we are having this is A, this whole term is B, so it is A minus B into A plus B. So when we open these squares, the answer you will get, that will be in the form tan square theta plus secant theta minus 1 whole square plus 2 tan theta into secant theta minus 1. We are saying this term we are considering it is A, this whole term we are saying it is B, so it is A square plus B square plus 2AB. In the denominator part it is tan square theta, minus sign is there, and what we are left with is, this is A minus B whole square, this term we are saying, so it is secant square theta minus 1 plus 2 times secant theta. Now when we open this whole square, we get it is tan square theta plus secant square theta plus 1 minus 2 secant theta plus 2 tan theta secant theta minus 1 over. Now what is the value of tan square theta minus secant square theta? We are talking about this term. It is tan square theta. Look at this second identity over here. So from this identity we will get that 1 is equal to secant square theta minus tan square theta. If we multiply both sides with minus 1, we will get minus 1 is equal to tan square theta minus secant square theta. So denominator becomes minus 1 plus 2 secant theta. In this term, in the numerator part, we are saying the term we have it is tan square theta plus 1. So the numerator will be, answer we are getting from this, it is 2 secant square theta, this 1 plus tan square theta, this is secant square theta. We already have another secant square theta, so that we are getting it is 2 secant square theta minus 2 secant theta plus 2 tan theta into secant theta minus 1 over minus 2 plus 2 secant theta. Now from this numerator, first of all we are cancelling this 2. We have taken 2 common from the numerator, we have taken 2 common from the denominator. From these two terms we are saying we have taken secant theta common, and what we are left with this secant theta minus 1. So our numerator will become secant theta plus tan theta into secant theta minus 1 over denominator is secant theta minus 1. Both these terms gets cancelled and we are left with the value secant theta plus tan theta, and we are saying that this is equal to RHS. Why? Because if we multiply this term with 1 plus sine theta and divide it with 1 plus sine theta, the answer we will get it is cos theta into 1 plus sine theta over. This term will become 1 minus sine square theta. What is 1 minus sine square theta? It is cos square theta. This cos theta and cos theta gets cancelled, and the answer we will get, this is 1 over cos theta plus sine theta over cos theta, and this value is equal to secant theta plus tan theta. This value we get, this is equal to secant theta plus tan theta. Now the next question we have, it is sin theta minus cos theta plus 1 over sin theta plus cos theta minus 1, and we have to prove that this is equal to 1 over secant theta minus tan theta. So if we look at this term, if we are multiplying it with secant theta plus tan theta and dividing it with secant theta plus tan theta, then this denominator part over here, this will become secant square theta plus minus tan square theta. It is secant square theta minus tan square theta, and this value is equal to 1. So we are saying that the right hand side over here, this is equal to secant theta plus tan theta. Now when we are talking about the left hand side, the term we have, it is sin theta minus we have taken common, and what we are left with is cos theta minus 1 over, it is sin theta plus cos theta minus 1. So we are multiplying this term and dividing this term with sin theta minus cos theta minus 1 and sin theta minus cos theta minus 1. So when you multiply these terms, the values you will get, it is sin square theta, then it is minus these two terms. We are saying it is this term square, and square of this term will be cos square theta plus 1 minus 2 cos theta. Then it is, this is a square plus b square, this is plus sign over here, and then it is minus 2 times sin theta into cos theta minus 1 upon, it is sin square theta minus cos theta minus 1 whole square. Now if we solve this term, it is, we are talking about this whole term, so what we get in place of this, it is minus cos square theta minus 1 plus 2 times cos theta. Now look at this value over here, sin square theta minus 1. Look at this first identity, so it is sin square theta minus 1, that is equal to minus of cos square theta. So this denominator part, we are saying this denominator part, and this will become, when we solve these values, this is in place of sin square theta minus 1, it is minus cos square theta, and the second term we have is minus cos square theta, so this will become minus 2 cos square theta plus 2 cos theta. So the denominator part will become this. In the numerator, this term we are saying it is sin square theta plus cos square theta, this value will be 1. So the numerator we will get, it is 2 minus 2 cos theta, then it is minus 2 sin theta into cos theta minus 1 divided by minus 2 cos square theta plus 2 cos theta. Now if we take 2 common from the numerator, so what we are left with is 1 minus cos theta, then we are writing it is plus sin theta into 1 minus cos theta over 2 cos theta into 1 minus cos theta. This numerator part we are talking about, this portion, this part we are saying, this 2 gets cancelled, and this term will become 1 plus sin theta into 1 minus cos theta. Now this 1 minus cos theta gets cancelled from both these terms, and what we are left with is 1 over cos theta plus sin theta over cos theta, and this value is equal to secant theta plus tan theta, and this is equal to right hand side, this value we are saying this is equal to the right hand side, and hence the proof. Now next we have cot theta. We are writing it as cot theta plus cosecant theta minus 1 over cot theta minus cosecant theta minus 1. We are multiplying this with cot theta plus cosecant theta minus 1 and dividing it with cot theta plus cosecant theta minus 1. So the answer we will get, it is equal to cot square theta plus cosecant square theta plus 1 minus 2 cosecant theta, and the next term we will get, it is equal to plus 2 cot theta into cosecant theta minus 1, and in the denominator we will get, it is cot square theta, next it is minus of cosecant theta minus 1 whole square. Now in the numerator part we are having, it is cot square theta plus 1. So this term, these two terms, this will become cosecant square theta. These two terms will become 2 cosecant square theta. In the denominator we are saying, in place of this term we can write it as minus cosecant square theta minus 1 plus 2 times cosecant theta. Now if you look at these two values, it is cot square theta minus cosecant square theta. Talking about these two values, it is cot square theta minus cosecant square theta. The value of this term will be, these two terms we are saying, this will be minus 1. So what answer we are getting is, it is 2 we have taken common from the numerator, and the terms we are left with is cosecant square theta minus cosecant theta plus 2 times cot theta into cosecant theta minus 1 upon, in the denominator we will get, it is this whole term. When we will solve, we are left with is minus 2 plus 2 cosecant theta. This 2 gets cancelled over here, this is 1 we are left with. From these two terms, if we take cosecant theta common, we are left with this cosecant theta minus 1. Suppose this 2 is also cancelled over here. So what we are left with is that cosecant theta plus 1 into, it is cosecant theta plus cot theta. What we are saying is, over here the term is cosecant theta minus 1, over here the term is cosecant theta minus 1. We have taken this term common, it is cosecant theta minus 1 we have taken common. So what we are left with is, it is cosecant theta plus cot theta. In the denominator part we have, it is cosecant theta minus 1. Both these terms gets cancelled. Now we can write cosecant theta as 1 over sin theta and cot theta as cos theta over sin theta, and this is equal to 1 plus cos theta over sin theta, and this is equal to RHS. So we have started with LHS, and the answer we are getting, it is equal to RHS, hence the proof. Now in this next question, we have to prove that square root of secant square theta plus cosecant square theta is equal to tan theta plus cot theta. So what we are going to do is, we are going to square both sides. On squaring this side, what we are left with is secant square theta plus cosecant square theta, and this side will become, it is tan square theta plus cot square theta plus 2 tan theta cot theta. Now what is the value of tan square theta? It is secant square theta minus 1. Cot theta is the secant square theta minus 1, and this value we are saying, this is equal to 1. So the answer we are getting, it is equal to secant square theta plus cosecant square theta, and that is equal to the LHS. s. Now next question we have, it is square root of 1 minus sine theta over 1 plus sine theta square root, that is equal to secant theta minus tan theta. Now one method to solve this problem, it is shown over here, that we have multiplied and divided this term with square root of 1 minus sine theta. This numerator part, if we look at, this will become whole square and it is 1 minus sine theta. The denominator part will become cos theta and you will obtain the answer by separating the denominator. The second kind of approach that you can use, it is you can square both these sides. So our question becomes 1 minus sine theta over 1 plus sine theta, that is equal to secant theta minus tan theta whole square. This will become secant square theta plus tan square theta minus 2 secant theta tan theta. So we can write it is equal to 1 over cos square theta plus sine square theta over cos square theta minus 2 1 over cos theta into sine theta over cos theta. If we take cos square theta as LCM, we are left with is 1 plus sine square theta minus 2 sine theta. So on solving this numerator part, we are writing it is 1 minus sine theta whole square, and denominator part it is 1 minus sine square theta. This 1 minus sine square theta, this will become 1 minus sine theta into 1 plus sine theta. So this 1 minus sine theta gets cancelled and what we are left with is 1 minus sine theta over 1 plus sine theta. So you can use either of these approaches. Either you can multiply and divide it with this term, or you can take the square on both sides. Similarly, in the next question, we have square root of 1 plus cos theta over 1 minus cos theta. So to solve this, we have multiplied and divided the numerator and denominator with square root of 1 plus cos theta. This numerator part will become whole square and this will give us 1 minus plus cos theta. This denominator part, we are saying we are using the formula a minus b into a plus b, and the value we have it is a square minus b square. So on solving this, we will get it is sine theta, and further on solving this, we will get the final answer as cosecant theta plus cot theta. To solve this part also, you can use the similar approach as we have used over here, that you can square on both sides and obtain the answer. So you can try this part at your own. Now next question we have it is, we have to prove that 1 square root of 1 plus sine theta over square root of 1 minus sine theta plus square root of 1 minus sine theta over square root of 1 plus sine theta, that is equal to 2 secant theta. So we have written this term in this form, that we have separated the square roots. And when we take the LCM over here, we will get the answer in the form, it is square root of 1 minus sine theta into square root of 1 plus sine theta. Then in the next step, the numerator part that we will get, it is 1 plus sine theta, and these terms, these are cross multiplied over here, and plus 1 minus sine theta. So these two gets cancelled and what we are left with is 2 over square root of 1 minus sine square theta. This is equal to 2 over cos theta, and that is equal to 2 times secant theta. Similarly, in this question, when we take the LCM over here, it is square root of secant theta plus 1, square root of secant theta minus 1. This is secant theta minus 1 plus secant theta plus 1. These two terms get cancelled. We are left with is 2 times secant theta over square root of secant square theta minus 1. This is equal to 2 times secant theta over square root of tan square theta. So the answer we are left with is 2 times secant theta over tan theta. So this term will become, it is 2 times 1 by cos theta into cos theta over sin theta. Cos theta gets cancelled and the answer we are left with is 2 times cosecant theta, and this is equal to RHS. Now next question we have, it is cosecant theta over cosecant theta minus 1 plus cosecant theta over cosecant theta plus 1. So if we take the LCM over here, it is cosecant square theta minus 1, and these terms will become cosecant square theta plus cosecant theta plus cosecant square theta minus cosecant theta. These two terms get cancelled and we are left with this 2 cosecant square theta over. Now what is the value of 1? Now the denominator is cosecant square theta minus 1 and the value of this is cot square theta. So on solving this, we will get this is 2 into 1 over sin square theta into, it is in the denominator, it is cot square theta, so it is sin square theta over cos square theta. This sin square theta gets cancelled and we are left with is 2 times secant square theta, and this is equal to RHS. So we have proved that LHS is equal to RHS. Next, we are saying that in order to show that a given trigonometric equation is not an identity, it is sufficient to find by hit and trial method a single value of theta which does not satisfy it. So we are saying if any identity is given to us, identity means that it is satisfied for all values of angle. So if we have to prove that something is not an identity, it is sufficient to prove for one angle that this does not hold for one angle theta, some value of theta, then it is not an identity. So next question we have is, this equation is given to us and we have to prove that it is not an identity. So to show this, we are saying if we put theta is equal to 30 degree in this equation, so the values we get, it is LHS we are talking about, it is cos square 30 minus sin square 30. The value of cos 30, it is root 3 by 2 square minus 1 by 2 square. The answer we get, it is 3 by 4 minus 1 by 4, that is equal to 2 by 4, that is equal to 1 by 2. When we are talking about the RHS, the value we get, it is 2 tan 30 over 1 minus tan square 30. So it is 2 into 1 by root 3. These values we are taking from the table we have studied in our previous lecture. It is 1 minus root 3 square, and on solving this, the answer we are saying it is root 3. So what we get is that LHS is not equal to RHS. We are saying that this equation, this is not an identity. So it is important to note over here that if suppose that this thing holds for some value theta 1, for just one value we are saying, then it doesn't make this an identity. We have to check for all values of theta, and it is not feasible to check any equation for all values of theta. So in place of checking it for all values of theta, we try to give the proof that this identity, it holds for all values of theta. We are not, when we are proving the identity, we are not checking it for each and every value of theta, because it is not a feasible process. Now in this next question, the first part we are considering the LHS. So it is sin square A into cos square B minus cos square A into sin square B. Now we can, the answers we want, they are in the form of sine. So in place of cos square B, we are writing it is 1 minus sin square B. In place of cos square A, we are writing it is 1 minus sin square A. and this time we are writing it is sine square b. So it is sine square a minus sine square a into sine square b minus sine square b plus sine square a into sine square b. Both these terms gets cancelled out and the answer we are left with is sine square a minus sine square b, and this is equal to RHS. Now next we have in the second part, we have it is tan square a into secant square b minus secant square a into tan square b, and the answer we require it is in terms of tan. So in place of secant square we are writing it is 1 plus tan square a. So it becomes tan square a into 1 plus tan square b minus 1 plus tan square a into tan square b. So we get it is tan square a plus tan square a tan square b minus tan square b minus tan square a into tan square b. These two terms gets cancelled and the value we are left with, that is equal to RHS. So we are saying LHS is equal to RHS. Now next it is, you have to prove these three terms, these are equal to each other. It is tan square a minus tan square b, that is equal to sin square a minus sin square b over cos square a into cos square b, and this is equal to cos square b into minus cos square a over cos square b into cos square a. So if we talk about these two terms, we are just writing, yeah, I am talking about this term, it is 1 minus cos square a minus 1 minus cos square b. I am talking about this numerator part. Denominators, they are same. So this will become 1 minus cos square a minus 1 plus cos square b, and this is cos square b minus cos square a, and this is the numerator part over here. So both these terms, these are equal. Now we are left with is that we have to prove that this value is equal to one of these values. So to prove this, we are writing it is sine square a over cos square a minus sine square b over cos square b. If we take the LCM over here, we will get it is cos square a cos square b. This term will become sine square a into cos square b minus sine square b into cos square a. Suppose we are the denominator part, we are saying they are same for both these cases. This denominator, they are same. Now for the numerator part, if we are proving it for the first case, that is sin square a minus sin square b, it means we are writing this cos square b and cos square a as, I am talking about this numerator part, it is sin square a into 1 minus sin square b minus sin square b into 1 minus sin square b. I am talking only about the numerator part. So this will become sin square a minus sin square a into sin square b minus sin square b plus sin square b into sin square a. This term it is a over here. So these two terms get cancelled and we are left with is sin square a minus sin square b, and this is the numerator over here. The next two terms we have already proved that these are equal. The denominator part it is equal, and the numerator part we are saying it is sin square a minus sin square b. This is sin square a minus sin square b. So we see that all these three terms, they are equal to each other. Next we have is elimination of trigonometric ratios. So we are saying the first question we have, if x is equal to a sin theta plus b cos theta and y is equal to a cos theta minus b sin theta, we have to prove that x square plus y square is equal to a square plus b square. So we are calculating x square plus y square. So value we are getting it is a sin theta plus b cos theta square plus a cos theta minus b sin theta square. So it is a square sin square theta plus b square cos square theta plus 2ab sin theta cos theta. Next, on opening the second term, we will get it is a square cos square theta plus b square sin square theta minus 2ab sin theta cos theta, and it is plus sign between these two terms. These two gets cancelled. If we take a square common from here and b square common from these terms, what we are left with is sin square theta plus cos square theta, it is equal to 1. This is cos square theta plus sin square theta, this is equal to 1. So the final answer we will get it is a square plus b square. We are saying this term sin square theta plus cos square theta, it is 1. Cos square theta plus sin square theta, it equal to 1. So we are getting the answer in this form. Now the next we have it is x is equal to a sin theta and y is equal to b tan theta. We are talking about these two values, these are given to us, and we have to prove that a square over x square plus b square over y square is equal to 1. So from this equation what we get is that x is equal to a sin theta. This gives us that a over x is equal to cosecant theta. Similarly, we have b over y is equal to cot theta. So x is, we are talking about the term that we have to evaluate now. It is a square over x square minus b square over y square, that is equal to cosecant square theta minus cot square theta. And look at this third identity over here. By using this third identity, we are saying this is equal to 1, and this is what we have to prove. Now the next we have is if tan theta plus sin theta is equal to m and tan theta minus sin theta is equal to n, we have to prove that m square minus n square is equal to 4 times square root of mn. Now when we are calculating m square minus n square, the value we are getting it is tan square theta plus sin square theta plus 2 tan theta sin theta, and then it is minus tan square theta minus sin square theta plus 2 tan theta sin theta. These tan square theta sin square theta get cancelled, and the answer we are left with is 4 tan theta sin theta. Now if we consider the left hand side, it is 4 times square root of mn. So that is 4 times square root of tan theta plus sin theta into tan theta minus sin theta. This term in the square root we are talking about, this is tan square theta minus sin square theta. We can write it as sin square theta over cos square theta minus sin square theta. I am talking about all these terms, these are in the square root, these are equal to each other, and this value is equal to 4 times square root of, if we take sin square theta common, we are left with is 1 over cos square theta minus 1. So this is 4 sin theta square root of 1 minus cos square theta over cos square theta. So it is 4 sin theta square root of sin square theta over cos square theta. So this is equal to 4 sin theta into tan theta, and both these values, these are equal to each other, and this is what we have to prove, that m square minus n square, that is equal to 4 times mn. It is square root of this value. Now next we have is if secant theta plus tan theta is equal to m, we have to show that m square minus 1 over m square plus 1, that is equal to sin theta. So we are calculating the value of m square minus 1, that will be equal to secant square theta plus tan square theta plus 2 secant theta tan theta plus 1. Now what we have is that tan square theta plus 1, that is equal to secant square theta, so we get it is 2 times secant square theta plus 2 secant theta tan theta. If we take 2 secant theta common, we are left with is it is secant theta plus tan theta. This is the value of m square plus 1. Next we are calculating the value of m square minus 1, so that will be we will have minus 1 over here. Now if we put minus 1 over here, it means we are talking about secant square theta minus 1 plus tan square theta plus 2 secant theta tan theta. Now secant square minus 1, this is tan square theta, so it becomes 2 tan square theta plus 2 secant theta tan theta. If we take 2 tan theta common, we are left with this secant theta plus tan theta. Now if we divide both these terms, we will get m square minus 1 over m square plus 1, that is equal to 2. When we substitute these values over here, it is 2 tan theta into secant theta plus tan theta over 2 secant theta into secant theta plus tan theta. Both these values gets cancelled, these two gets cancelled, and we are left with this sin theta over cos theta into 1 over cos theta, and the answer we are getting it is sin theta, and that is equal to RHS. We are saying LHS equal to RHS. Next is, if sin theta plus cos theta is equal to m and secant theta plus cosecant theta is equal to n, we have to prove that n into m square minus 1, that is equal to 2 times m. So we are writing n into m square minus 1. So we are saying this is equal to secant theta plus cosecant theta into the value of m square that we will have, it is sin square theta plus cos square theta plus 2 sin theta cos theta, and it is minus 1 over here. Now this term sin square theta plus cos square theta is equal to 1. This 1 and minus 1 gets cancelled, and the answer we are left with is this is equal to 1 over cos theta plus 1 over sin theta into 2 times sin theta cos theta. If we take sin theta cos theta as LCM, we are left with this cos theta plus sin theta into 2 times sin theta cos theta. This sin theta cos theta gets cancelled, and this value we are saying cos theta plus sin theta, this is equal to m. So the answer we are left with is 2m, and this is what we have to prove, that LHS, that is equal to RHS. Now next we have, we have to prove, given that cos theta plus sin theta, that is equal to root 2 times cos theta. This value is given to us. We have to prove that cos theta minus sin theta is equal to root 2 sin theta. So we are starting from this equation. We are writing it is cos theta plus sin theta, that is equal to root 2 times cos theta. When we square both sides of this equation, we get it is cos square theta plus sin square theta plus 2 cos theta sin theta, that is equal to 2 cos square theta. So this gives us that if we look at these values over here, the answer we require, it is cos theta minus sin theta. So it means in place of this plus sign we require, it should be minus sign we require. So we send this term on this side. So what we get is that cos, or we are writing it as sine square theta, that is equal to cos square theta minus 2 cos theta sine theta. To make it whole square, we are adding sine square theta on both sides of this equation. This whole term, this will become 2 sine square theta, and this whole term now, this will be cos theta minus sine theta square. So if we take the square root on both the sides, the answer we will get it is square root 2 sine theta, that is equal to cos theta minus sine theta. We are saying square root 2 sine theta, that is equal to cos theta minus sine theta. Next is, if sine theta plus sine square theta is equal to 1, we have to prove that cos square theta plus cos 4 theta is equal to 1. So from this equation, we are saying sine theta, that is equal to 1 minus sine square theta, and 1 minus sine square theta is, from this first identity, it is equal to cos square theta. Now this gives us cos square theta is equal to sine theta, and cos 4 theta will be equal to sine square theta. If we substitute both these values in this equation, we are talking about the left hand side, now we have it is cos square theta plus cos 4 theta. We are saying cos square theta, that is equal to sine theta, and sine cos 4 theta, that is equal to sine square theta, and this value from the given equation, this is equal to 1. So we are saying this is equal to RHS. Now next we have is, if cos theta plus sine theta is equal to 1, then we have to prove that cos theta minus sine theta is equal to plus minus 1. So from this equation, if we square the values, we get it is cos square theta plus sine square theta plus 2 sine theta cos theta is equal to 1. This whole term, this is equal to 1. So we get 2 sine theta cos theta is equal to 0. Now we want to find the value of cos theta minus sine theta. So we are writing cos theta minus sine theta square. We are calculating the value of this term. We are saying consider this, and this value will be equal to cos square theta plus sine square theta minus 2 sine theta cos theta. The value of 2 sine theta cos theta, we are saying this term is equal to 0, and this whole term, this will be equal to 1. So what we get is that cos theta minus sine theta square, this is equal to 1. So we get cos theta minus sine theta, this value will be equal to plus minus 1. Now next we have is, if x sine cube theta, this x sine cube theta plus y cos cube theta, this is equal to sine theta into cos theta, and x sine theta is equal to y cos theta, we have to prove that x square plus y square is equal to 1. So this term we can write, it is sine theta, sine square theta we take common from this, so we are left with this x sine theta plus y cos cube theta, that is equal to, in place of y cos cube theta, we are writing it is y cos theta into cos square theta, this is equal to sine theta into cos theta. Now from this second equation, y cos theta, it is given equal to x sine theta. So what we get for this term, we can write y cos theta as x sine theta. So if we take x sine theta common from both these terms, We are saying over here it is x sine theta, over here it is x sine theta. So what we will be left with is sine square theta plus cos square theta, that is equal to sine theta into cos theta. This term is equal to 1. Sine theta and sine theta gets cancelled and we get it that x, that is equal to cos theta. This is the first value we are getting, that x is equal to cos theta. Now if we put this value in this equation, we get cos theta into sine theta, that is equal to y cos theta. So this cos theta gets cancelled and we get y is equal to sine theta. Now what equation we have? It is x square plus y square is equal to 1. So what is x square plus y square? It is cos square theta plus sine square theta, and by the identity 1 we know that this is equal to 1, and this is what we have to prove. Next is, if x is equal to a secant theta cos phi and y is equal to b secant theta sin phi and z is equal to c tan theta, we have to prove that x over a square. So what is the value of x over a from this? We are saying this is equal to secant theta. Value of y over b we have, it is secant theta cos phi. The value of y over b we have, it is secant theta sin phi, and value of z over c we have, it is tan theta. So we are calculating the value of x square over a square plus y square over b square, and the answer we get, it is secant square theta cos square phi plus secant square theta sin square phi. If we take secant square theta common, we are left with this cos square phi plus sin square phi. What is the value of cos square phi plus sin square phi? It is, this value is equal to 1. So answer we are left with is secant square phi. And by our identity 2, we are writing it is 1 plus tan square. This is not secant square phi, this is secant square theta. And the answer we are getting, it is tan square theta. And tan square theta we have, it is 1 plus z by c square. And this is what we have to prove. Next we have x is equal to r sine alpha cos beta, y is equal to r sine alpha sine beta, and z is equal to r cos alpha. We have to prove that x square plus y square plus z square equal to r square. So when we are scaling these terms and adding, we are getting it is r square sine square alpha cos square beta, r square sine square alpha sine square beta, and r square cos square alpha. We are adding these three terms. From the first two terms, we can take r square sine square alpha common. I am talking about these two terms first. So we are taking r square sine square alpha common, and we are left with this cos square beta plus sine square beta, and this term we are saying this is equal to 1. So our question becomes, or this whole equality, this is equal to r square sine square alpha plus r square cos square alpha. If we take r square common, we are left with this sine square alpha plus cos square alpha. Sine square alpha plus cos square alpha is 1. So the answer we get, it is r square, and this is what we have to prove, that x square plus y square plus z square is equal to r square. Next is, if secant theta minus sine theta is equal to m and secant theta minus cos theta is equal to n, you have to prove this term. You have to prove this equality. So the values we require, it is m square n. So what is m square n? It is secant theta minus sine theta square into secant theta minus cos theta. So this is 1 over sine theta minus sine theta square into 1 over cos theta minus cos theta. When we take LCM over here, we are getting it in the denominator it is sin theta, and in the numerator it is 1 minus sin square theta. 1 minus cos square theta over cos theta, and it is whole square over here. So this numerator part we are saying this will become cos square theta over sin theta into sin square theta over cos theta. Now this cos theta and this cos theta gets cancelled. It is whole square over here. So what we get is this value is cos 4 theta over sin square theta into sin square theta over cos theta. These two gets cancelled and we are left with this cos cube theta. So we are saying the value of m square n, it is cos cube theta. Similarly, when we calculate the value of mn square, the answer we will get this is equal to sin cube theta. You can check these calculations over here that we have substituted the values. We have opened the whole square in this term and the answer we are getting it is sin cube theta. So we have two values now. One is m square n raised to the power 1 by 3, that is equal to cos theta. Second is mn square raised to the power 1 by 3, that is equal to sin theta. If we square both these equations and add both these equations, the answer we will get it is m square n raised to the power 2 by 3 plus mn square raised to the power 2 by 3, that is equal to 1. Cos square theta plus sin square theta, that is equal to 1. So we are saying that we obtain this equality, we have proved this equality. Next is if a cos theta plus b sin theta minus b sin theta is equal to c, we have to prove that a sin theta plus b cos theta, that is equal to plus minus square root of this term. So the answer that we require, it is in this form. So if we consider the term a sin theta plus b cos theta square, the value we have it is a square sin square theta plus b square cos square theta plus 2ab sin theta cos theta. You get this answer is equal to this. Now if we look at this term over here and we square both sides, it is a square cos square theta plus b square sin square theta minus 2ab sin theta cos theta, and we are saying this value is equal to c square. So from this equation we can see that the value of 2ab sin theta cos theta, that is equal to a square cos square theta plus b square sin square theta minus c square, that is equal to 2ab sin theta cos theta. We substitute this value over here. We are calculating the value of this term. So the answer we will get, we are talking about, this will be equal to a square sin square theta plus b square cos square theta, and these values, these are plus a square cos square theta plus b square sin square theta minus c square. From these two terms we are talking about, we can take a square common, we will be left with sin square theta plus cos square theta. So the answer we will get it is a square. From these two terms we will take b square common, we will be left with cos square theta plus sin square theta, it is 1, and last we are getting it is minus c square. So what we get is that a sin theta plus b cos theta whole square, this is equal to a square plus b square minus c square. So this gives us a sin theta plus b cos theta, this is equal to plus minus square root of a square plus b square minus c square, and this is what we have to prove. This is the equality that we have to prove. Next is, if 3 sin theta plus 5 cos theta is equal to 5, we have to prove that 5 sin theta minus 3 cos theta is equal to plus minus 3. So again we are talking about this term. It is 5 sin theta minus 3 cos theta. We want squares on this term, so we have started solving from this term, that we have squared this term and we are trying to find the value of this. So it is 25 sin square theta plus 9 cos square theta minus 30 sin theta cos theta. Now look at this term over here. If we square both sides, we will get it is 9 sin square theta plus 25 cos square theta plus 30 sin theta cos theta, that is equal to 25. So we will get the value that 30 sin theta cos theta, that is equal to 25 minus 9 sin square theta minus 25 cos square theta. So if we substitute this value 30 sin theta cos theta over here, we will get, in place of this value we are substituting it over here. So we are having it is 25, then it is minus 25 cos square theta minus 9 sin square theta. It is minus sign over here. We are talking about this sign over here. It is minus sign. It means all these terms, these are subtracted. So what we get from these two terms, we can take 25 common. We will be left with sin square theta plus cos square theta. We are saying it is minus 25. We are taking 25 common, and from the next term we will get it is 9 is common, and we are left with this sin square theta plus cos square theta. Similarly over here we are left with this sin square theta plus cos square theta, and we know that both these values, these are equal to 1. This 25 get cancelled and we get the answer is 9. So we get that 5 sin theta minus 3 cos theta square, this is equal to 9. So this gives us 5 sin theta minus 3 cos theta, that is equal to plus minus 3. And this is what we have to prove, that 5 sin theta minus 3 cos theta, that is equal to plus minus 3.